everyone. I am Dr. Manoj Kumar Sharma, Associate Professor, ITS College of Pharmacy. Today, I am teach you non-parametric test, lecture 18. This is the lecture from the course Bachelor in Pharmacy, and the subject is Biostatistics and Research Methodology. The code is BP801T and the university is Dr. APJ Abdul Kalam Technical University. So, this is the non-parametric test part 1 of unit 3. In this lecture, we will cover about the introduction of the non-parametric test, then we will read Wilcoxon sign rank test and then Mann-Whitney-U test. So, first of all, non-parametric test, it is these are the test of significance, that means to test the significance of the data. So, non-parametric test, most of the statistical tests referred to as parametric require the use of interval or ratio scaled data. Non-parametric tests are often the only way to analyze nominal or ordinal data and draw statistical conclusions. Non-parametric tests require no assumption about the population probability distribution, as in parametric test it should require that the data should be normally distributed for parametric test, but in non-parametric test there is no requirement. Non-parametric tests are used when data is not normally distributed or it is skewed data. Non-parametric tests are often called distribution free test, because we can apply these tests when data is not normally distributed. In general, for statistical test to be classified as non-parametric, it must be satisfied at least one of the following condition. The test can be used with the nominal data, the test can be used with the ordinal data, the test can be used with interval or ratio data when no assumption can be made about the population probability distribution. So, these are the conditions for the non-parametric test. Now, the advantage of non-parametric test, these tests are used with all scales. It is easier to compute and it developed originally before wide computer use. It requires fewer assumptions and need not involve population parameter. So, these are the advantages of parametric test, and results may be as exact as parameters procedures. So, non-parametric tests are distribution free test, and when our data is not normally or skewed data, then we apply non-parametric test. And there are different types of non-parametric test like Wilcoxon sign rank test, Mann-Whitney-U test, Kruskal-Wallis test. There are some disadvantages in non-parametric test. It may waste information if data point using parametric procedures. For example, when we converting data from ratio to ordinal scale. For example, as in age, if we categorize this data into adolescent, young, old, etc., then some information may be waste. It is difficult to compute by hand for large samples, and some tables are not widely available for these tests. So, these are the disadvantages of non-parametric test. The first non-parametric test is Wilcoxon sign rank test. This test is the non-parametric alternative to the parametric method sample test. So, it is used for the comparison of two treatments in a paired design. That means, when we have paired data then we apply Wilcoxon sign rank test. We can say it is the alternative of the paired t test. It is more sensitive non-parametric test than the sign test. So, be remember Wilcoxon sign rank test is generally used when we have paired data. For example, we want to compare the pre and post values of a subject. Wilcoxon sign rank test, the methodology of the parameters matched sample analysis require interval data and the assumption that the distribution of comparative treatment are symmetrical. That means, data should be normally distributed or it has bell shaped curve. Therefore, we are testing the equality of the means and medians, but if the assumption of normally distributed difference is not appropriate, then Wilcoxon sign rank test can be used for matched pair data. Wilcoxon rank test, the preliminary steps for this test are: first we compute the difference between the paired observation, then discard any differences if it is 0, then rank the absolute value. Be remember, when we assigning the rank for the difference, we take the absolute value of the difference from the lowest to highest, and tied differences are assigned to the average ranking of their positions. Then give the ranks the sign of the original difference in the data, then find the sum of the sign ranks. Next, we will determine whether the sum is significantly different from 0. For example, this is the case for the data in the given table which were obtained to compare the time to peak plasma level for 2 oral formulation of the same drug. Pair data obtained from the bioavailability experiment. This is the data in which we have 12 subjects, and this is the time to peak for 2 oral formulation. For first group, the time to peak for first subject is 2.5, and for in B formulation then it is 3.5. For A, subject 2 have value 3.0, and for B same subject 2 have 4.0. So, this is the matched sample cases, and we solve it with the help of Wilcoxon sign rank test. When we apply Wilcoxon test for the solution, first we write the null hypothesis. The null hypothesis to be tested, the median difference is 0. That means, the median of first sample and second sample are equal. Then, so the alter H naught, the median of the difference is 0, or the sum of positive ranks equal to the negative ranks. The alternative hypothesis, the median of the difference is negative. That means, the positive rank less than the negative rank. Third step is we write the level of significance, and in standard condition we take alpha is 0.5%. Alpha for standard condition we take generally 0.5%. We also take it 0.01, and in some cases we take it 0.001. Now, the solution is, the first step is we first find the difference of A and B. So, A value of A is 2.5 and B is 3.5, and the difference B minus A equal to 1 plus 1. When 4.0 subtract 3, we get plus 1, then 2.5 minus 1.25 equal to plus 1.25. Similarly, we subtract 1.75 from 2 for sample 4 and it will be equal to plus 0.25, and for sample 5 when we subtract 3.5 from 3.5 we get the difference is 0, then 4 minus 2.5 equal to plus 1.5, then 1.5 minus 1.75 for subject 7 and it will be equal to minus 0.25, and so on. We find the all the difference as for the last samples. After finding the difference we assign the rank. So, before assigning the rank we write these values ignoring the sign in minimum to maximum. So, first value minimum is 0.25, then minus 0.25 plus 0.25 plus 0.25. We remember when we write these values of difference we ignore the sign. So, the first 3 minimum value are 2.5, 2.5, 2.5, then we write 5, 5, 5, 0.5, 0.5, 0.5, then 1.0, 1.0, 1.25, 1.5 and 1.5. Now, we first rank the difference values ignoring the sign. So, for this 0.25 we write 1, for this 2.5 we rank 2 and for third 2.5 rank 3. But we see here these 1, 2, 3 ranks are tied for the same observation or same value, because one rank have value 0.25, 2 rank also have 0.25, 3 rank also have 2.5. So, here ranks are tied. So, when ranks are tied we find the average rank of this. So, for this the average of rank is 1 plus 2 plus 3 divided by 3 and it will be equal to 6 by 3 and it equal to 2. So, the assigned rank for these 3 values is 2, 2 and 2. After that we rank the next value 0.5 to 4, for next 0.5 to 5 and next for 0.5 to 6, and here again the ranks are tied. So, we again find the average rank for 0.5 and the average rank is equal to 3 plus 4 plus 5 upon 3 and this is equal to 4, 5 and 6, 4, 5 and 6 and this is 15 by 3 and so the rank for all 0.5 is 5, 5, 5. So, this is the assigned rank. Then for next value plus 1.0 we give the rank 7 and for next plus 1.0 we give the rank 8 and again here the ranks are tied and we find the average for this and the average for this equal to 7 plus 8 upon 2, this is 15 by 2 and this will be equal to 7.5. So, in this way we find the average assigned rank for these two values 7.5, 7.5. For next plus 1.25 we give the rank 9 and here ranks are not tied. So, the assigned rank for 1 plus 1.25 is 9 and for next 1 plus 5.5 the rank is 10 and for next value the rank is 11 and we see here the ranks are again tied. So, we again find the average of this and the average of 10 plus 1 divided by 2, this is 21 by 2 and this will be equal to 10.5. So, the assigned rank for this is 10.5 and 10.5. Now, we assign the sign rank for the assigned rank. So, these are the assigned rank with sign. So, and this will be equal to as this 2 rank for minus 0.25. So, we take minus, and this rank 2 is plus 2.5. So, we take plus. That means, we assign the sign here according to the difference value. After that, assigning the sign, we find the sums, and we find the rank with the positive sign. We find the sum of positive sign, that is 2 plus 2 plus 5 plus 5, 7.5, 7.5 plus 9 plus this, and it will be equal to 59. That means, we first find the sum of the positive ranks, then we find the sum of the negative ranks, or you can say we find the sum of rank with negative sign, and the negative sign, if you see here, there are only 2 negative sign rank, minus 2 and minus 5, and the sum of these minus 2 and minus 5, minus 2 minus 5, this will equal to minus this is 7. We cannot consider here sign, the 2 plus 5 is 7 when we find the sum. So, the rank with positive sign is 59 and the rank with negative sign is 7, and the inference is, since the smaller rank is 7 and from the standard table for the sample size 11, as the sample size of our example is 11, the value is 10, but the smaller rank our 7 is smaller than the 10. So, we accept the null hypothesis, and there is a smaller rank is 7 and from table the sample size 11, the value is 10. So, there is a significant difference. We also find for large sample Wilcoxon sign rank test with this formula, z equal to r minus n into n plus 1 divided by 4 square root of n into n plus 1 half into n plus 1 divided by 12, where r is the sum of ranks with positive sign and n is the sample size. So, r is in our example is 59, as we have find here the rank with positive sign is 59. So, we take greater value r is 59 minus n 11 plus 1 divided by 4 and then 11 plus half into 12, that is 11 plus 1 and whole divided by 12, and on solving this we find the value is 2.31, and for the standard condition, that means for alpha 0.5, the value of z for this is 2.31 and the p value for this is 0.02. So, as the p value is 0.02, so this is a significant difference. That means, this calculated value is greater than the standard value of z. So, the p value is 0.02 and we accept the alternate hypothesis, and we consider that there is a significant difference between the two formulation, as we consider in this example the median, that means median difference is 0, or you can say the time to peak for both formulation have a significant difference. Next is Mann-Whitney-U test. This test is another non-parametric method for determining whether there is a difference between the two population. This test is unlike the Wilcoxon sign rank test, and this test is not based on the matched sample. So, this test is used for two independent groups, because the data is not matched group or not paired data in Mann-Whitney-U test, while in Wilcoxon sign rank test we have matched sample data or paired data. This test does not require interval data or the assumption that both population are normally distributed, as it is a non-parametric test. So, it is a not require the normality of the population of the data. the only requirement is that the measurement scale for the data is at least ordinal. We remember, the only requirement is that the measurement scale for the data is at least ordinal data. Mann-Whitney-U test is also known as Wilcoxon rank test. Instead of testing for the difference between the means of two populations, this method test determine whether two populations are identical. That means, in this test we take the null hypothesis that both populations are identical. The hypothesis that the two populations are identical and the alternate hypothesis that the two populations are not identical. A researcher designed an experiment to assess the effects of prolonged inhalation of cadmium oxide. 15 laboratory animals served as experiment subject with 10 similar animals served as control. The variable of interest was hemoglobin level. Following the experiment, the results are shown in the table. We wish to know if we conclude that prolonged inhalation of cadmium oxide reduced the hemoglobin level. This is the given data. In this we have X animals which are exposed and the Y animals in group are not unexposed group, and these are the hemoglobin level given in this table. So, to find the solution of this, we first assumption, we presume that the assumption of the Mann-Whitney test are met, and the null hypothesis for this is the median of X group is greater than or equal to the median of Y group, while the alternate hypothesis is median of X group is less than the median of Y group, and we take the level of significance is alpha equal to 0.5%, and the test statistic is t equal to s minus n into n minus 1 by 2, where n is the number of sample of X observation and s is the sum of the ranks assigned to the sample observation from the population of X value. The choice of samples value we label as X is arbitrary. We remember, the choice of which sample values or we label is X is arbitrary. So, these are the values of X and Y. So, we assigning the ranks, the this is the minimum value 13.7. So, we give rank 1 13.8, rank 2 14.03 and so on. But when we assigning the rank, we continuously assign the rank for X and Y value. We remember, after like this, you see here 14.4, the next upper value in Y 15.0, then next value 15.3 next. So, we assign first 7, then 8 rank for this, 9 rank for this, and here the ranks are tied and we find the average for 15, then for 15.3 we assign rank this these two value 15.3. So, 11 and 12. So, this is 8 and 9, then find for tied rank for this and for 15.6 12. So, we continuously assign the rank for 2 and 3 and O. Now, we find the sum of the ranks S equal to 145. Now, calculation of test statistic, we have S equal to 145. So, that t equal to 145 minus 15 into 15 plus 1 and so on, and we find the t equal to 25. So, what is the inference? When we enter the table k with n equal to 15 and m equal to 10 for alpha 0.5, we find the critical value is 39, and since our calculated value 25 is less than the standard tabulated value 39. So, we reject the null hypothesis and we conclude that mx is smaller than mi. This leads us to conclusion that the prolonged inhalation of cadmium oxide does reduce the hemoglobin level. This is the table for this. Thank you.